everyone, welcome back to NIIT. Today, we're diving into a topic that's been buzzing around in the world of technology, quantum computing. You've probably heard the term, but what does it actually mean for our future? How does this futuristic technology work? And why should we care? Well, in this video, we're going to break it all down. So, grab a seat and let's get started. First things first, let's talk about what quantum computing really is. If you've ever been confused about it, you're not alone. To put it simply, quantum computing is a type of computation that harnesses the strange, almost magical principles of quantum mechanics, the science that explains the behavior of particles at the smallest scales. Think atoms, electrons, and photons. Now I know what you're probably thinking. That sounds like something straight out of a sci-fi movie. And you're right to feel that way. But here's where it gets interesting. Quantum computing is no longer just a concept. It's rapidly evolving from theory into something we're starting to use in the real world. And if we can make it work, it will change the game in ways we can't even fully imagine yet. So how does it actually work? Traditional computers like the one you're probably watching this video on process information in bits. These tiny units of data that can either be 0 or 1. But quantum computers, they use qubits. And here's where things get wild. Unlike regular bits, qubits can exist in multiple states at once, thanks to the magic of superposition. Imagine flipping a coin. In the classical world, it can either land heads or tails. But in the quantum world, where the coin is spinning, it's both heads and tails at the same time. This ability to exist in multiple states simultaneously gives quantum computers an exponential advantage over classical ones, especially when solving really complex problems. But wait, there's more. That's just one part of the magic. The other key principle of quantum computing is entanglement. This is when two qubits become linked together so that the state of one qubit is directly tied to the state of the other, no matter how far apart they are. Imagine being able to send a signal or compute something without any delay, even over vast distances, instantaneous communication across the world or even the universe. Okay, so now that we've covered the basics, let's get to the exciting part. What does all this mean for the future? Well, let's start with business and industry. Right now, there are some problems that classical computers just can't solve efficiently. Things like simulating complex chemical reactions, optimizing supply chains, and factoring large numbers. But quantum computers could change that. For example, pharmaceutical companies could use quantum computers to discover new drugs by simulating the behavior of molecules in ways traditional computers can't even begin to match. Quantum computing also has huge potential in cryptography, the art of protecting data. Currently, much of our data security relies on encryption algorithms that would take traditional computers millions of years to crack. But a sufficiently powerful quantum computer could potentially break those codes in a fraction of time. Sounds a little scary, right? But here's the good news. We're also developing quantum encryption techniques to safeguard our data from these future threats. And don't even get me started on the financial industry. Quantum computing could totally transform everything from risk analysis to portfolio optimization and trading algorithms. Imagine being able to simulate millions of market scenarios in real time to make better decisions on investments. That's the power of quantum computing could bring. But quantum computing is not just about business. It's also about solving some of the world's biggest problems. Think about climate change. With quantum computing, scientists could simulate environmental models with an unprecedented level of accuracy, leading to better climate models and potentially discovering new materials for clean energy. It could help us unlock the solutions to some of the most pressing challenges we face as a planet. Now, we've talked about the potential of quantum computing, but like any new technology, it's not without its challenges. For one, quantum computers are extremely fragile. Qubits are highly sensitive to their environment, so even the tiniest disruption can cause them to lose their quantum state, what we call as decoherence. This makes building and maintaining quantum computers really tricky. Plus, we're still in the early stages of quantum computing. Right now, we have quantum computers that are only able to solve very specific problems. It'll take time, research, and a lot of investment to scale this technology into something that's truly accessible for everyone. But here's the thing, we're making progress. Major players in the tech industry like IBM, Google, and even startups are working on developing quantum hardware and software. And that means we're not that far away from seeing real-world applications that can impact everything from healthcare to national security. So, where do we go from here? Well, the future of quantum computing is incredibly exciting. As the technology matures, it will continue to disrupt industries and change the way we think about computing. We might even look back in 10 or 20 years and realize this was the technology that truly transformed our world, like the way the internet did in the 90s. Quantum computing is still in its infancy, but the possibilities are endless. It could lead to breakthroughs we can't even predict yet. And if you're looking to be at the forefront of technological innovation, this is definitely an area you'll want to keep an eye on. Alright, that's a wrap for today's video. If you found this fascinating, make sure to hit that like button, subscribe, and ring the bell for more videos about future of technology. And don't forget to check out NIIT's certification programs in high-demand technologies like artificial intelligence, machine learning, cybersecurity, and more. Link in the description. Thanks for watching, and I'll see you in the next video.